Imagine a machine that could look at the universe and figure out something no human ever has. Not just crunch numbers faster, but actually discover. Right now, artificial intelligence is solving scientific problems once thought impossible, cracking puzzles that stumped experts for decades. So it raises a thrilling and slightly unnerving question. Could a machine one day make a breakthrough as world-changing as Einstein's, or even reach discoveries beyond human capability? The real answer is more surprising than a simple yes or no. So stay to the finish. Start with what artificial intelligence is already doing. What can these machines actually accomplish in science today? Far more than most people realize. One famous system solved a problem that had stumped biologists for 50 years, predicting the detailed shapes of proteins, the tiny machines inside every living cell. This was such a massive leap that its creators were awarded a Nobel Prize. That single breakthrough now helps millions of researchers around the world work on everything from new medicines to vaccines. A flood of progress unlocked by one artificial mind. That was only the beginning. What else has artificial intelligence discovered? An astonishing range of things. Other systems have designed brand new materials that scientists had never imagined, discovering millions of possible stable crystals in a fraction of the usual time. Artificial intelligence has helped uncover new antibiotics, sped up the hunt for life-saving drugs from years down to months, and tackled advanced mathematics problems at a level that once required brilliant human specialists. In field after field, these tools are pushing past limits that once seemed fixed. This points to a powerful new way of doing science. How is artificial intelligence changing the process itself? By acting as a tireless thinking partner. A human scientist can only read so many papers, run so many experiments, and hold so many ideas in mind at once. An artificial system can scan enormous mountains of data, spot hidden patterns, and suggest connections across different fields that a person might never notice. It never gets tired, never gets bored, and can explore thousands of possibilities while a human sleeps. That is a staggering amount of brain power aimed at hard problems. Some of the newest systems go even further. What are these so-called artificial scientists? They are programs designed to do more than assist. A new wave of tools can now plan their own experiments, control robots to carry them out, analyze the results, and even write up the findings, all with very little human help. In some labs, these systems run experiments around the clock, chasing ideas and testing them automatically. It is a glimpse of a future where machines do not just help with research, but actively drive it forward on their own. So this brings back the big question. Could a machine become the next Einstein? Here is where the answer gets interesting, because there is a crucial difference between two kinds of genius. Most scientific progress comes from combining existing ideas in clever new ways, and artificial intelligence is becoming spectacular at exactly that. It can stitch known methods together and surface links between fields faster than any human. For this kind of discovery, machines are already proving to be powerful and sometimes superhuman partners. But Einstein represented something different and rarer. What made his genius so special? He did not just combine old ideas. He invented entirely new ways of understanding reality, imagining concepts like bending space and time that nobody had framed before. That kind of leap, creating a brand new framework from scratch, is the deepest form of discovery. And so far, this is exactly where today's artificial intelligence still falls short. Inventing a completely original theory, the way Einstein or Newton did, remains beyond what these systems can do. The limits show up clearly when the problems get hard enough. Where does artificial intelligence still struggle? On the most difficult and original challenges. On the very hardest research-level math problems, even the best systems succeed only a small fraction of the time. They can also fail at surprisingly simple tasks and state wrong answers with complete confidence, which makes them risky to trust blindly. Experts stress that human oversight is not optional. For now, these tools are brilliant assistants, not independent geniuses ready to replace human minds. There is even a warning from some of the field's own leaders. Could the current boom actually slow real discovery? A few top researchers worry it might. They caution that chasing flashy commercial uses of artificial intelligence could pull attention away from the slow, deep work that leads to true breakthroughs. There is also concern that systems good at summarizing existing knowledge might undervalue the messy, original experiments that actually create new knowledge. Raw speed and scale, in other words, are not the same thing as genuine genius. A real example shows both the promise and the limits at once. One company spun out of this research is using artificial intelligence to design brand new medicines, and its computer-designed drug candidates are now moving toward their first tests in human patients. That is a remarkable leap, the kind of work that once took armies of scientists many years. Yet even here, humans remain deeply in the loop, guiding the process, checking the results, and making the final calls. The machine accelerates the search dramatically, but people still steer it toward what matters and decide what to trust. So what does the future most likely hold? Probably not a lone robot Einstein working in isolation. The more realistic and exciting picture is a powerful partnership. Human scientists bring curiosity, intuition, and the ability to ask brand new questions, while artificial intelligence brings unmatched speed, memory, and pattern finding. Together they can move faster than either could alone. The next great breakthrough may not come from a machine or a person, but from a human and an artificial mind working side by side, each doing what it does best. Humans still bring something machines do not. A person can feel a sense of wonder, get nagged by a question that does not fit the textbooks, and chase it purely out of curiosity. Einstein famously imagined what it would be like to ride alongside a beam of light, a strange, playful thought that led to a revolution in physics. That kind of imaginative spark, driven by feeling and curiosity rather than data, is something no current machine truly has. It may be the most human ingredient in discovery, and for now it remains ours alone. That partnership could still transform the world. Why does this matter so much? Because even as a powerful tool, artificial intelligence could help crack problems that have stumped humanity for generations. Diseases without cures, the challenge of clean energy, the mysteries of the brain, all of these might yield faster, with these systems helping at every step. If artificial intelligence can speed up discovery even a few times over, breakthroughs that would have taken generations could arrive within a single lifetime instead. So can artificial intelligence create the next Einstein? Not on its own, at least not yet. The deepest, most original leaps of genius still belong to the human mind. But as a partner, artificial intelligence is already making discoveries that humans never could have reached alone, and it is reshaping science at a breathtaking pace. The next Einstein may well be a person, but standing beside them, helping them see further than anyone in history, could be a machine. And that partnership might just be the most powerful force for discovery the world has ever known. If this fascinated you, give the video a like and subscribe for more. Tell us in the comments whether you think a machine could ever truly outthink a human. Mindware Vault has more ahead, so stay with us.